systems of equations by graphing. So the benchmarks that we're focused on are 9.1 and 9.6. 9.1 states that given a mathematical or real-world context, we need to write and solve a system of two-variable linear equations algebraically or graphically. And 9.6 is given a real-world context, represent constraints as systems of linear equations or inequalities. Interpret solutions to problems as viable or non-viable options. So that's what we're going to be working with this week or in this module. Systems of equations are a set of two or more equations with the same variables. So this first part, our goal is to learn is that classify systems of equations and writing equations of systems of equations. So a system of two linear equations can have one solution, infinite solutions, or no solutions. So just make note that you will not always have just one solution to a system. You could have no solution and you could have infinite solutions as well. All right. First of all, let's take a look at what these different types of solutions look like. So if we have intersecting lines like we do in this first graph, we're going to first match this equation. So the equation of this line is y is equal to negative 2x plus 1. And I know that because my y-intercept is a positive 1, and my slope here is a negative 2. You can see I go down 2 and to the right 1, which is a negative 2 slope. The equation for this line is y is equal to 2x plus 1. Again, I know that because my y-intercept is 1 and my slope here is a positive 2. I went up 2, 1, 2, and to the right 2. So my solution of these intersecting lines, of these two lines, it's going to be this point right here. What that's telling you is that this point, this ordered pair, is going to work for both this equation and this equation. And the value of that ordered pair is 0, 1. So there is one solution here, and that one solution is 0, 1, because that's that ordered pair that falls on that point where they intersect. The next type of solution we could have is an infinite solution, and that's when we have the same lines. So even though this may not be apparent or obvious to you that this is the same line, when I look at y is equal to negative 2x minus 1, I know that this is that line because at negative 1, that's my y-intercept. I went down 2, and to the right 1. So from here, I went down 2 and to the right 1. Now, the next equation, 2x plus y is equal to negative 1. Well, if I rewrote that in slope-intercept form, y is equal to negative 2x minus 1, then I would see that these are the exact same lines. And when I can see that, I know that I have infinite solutions. All right. Now, in our last type of systems of equations, we have parallel lines. And again, this is not always going to be obvious because a lot of times they will give us an equation in standard form and an equation in slope-intercept form. But in case they do, in this instance, we can see that this line matches up with this equation, negative 2x plus 4. And this line matches up to the equation y is equal to negative 2x minus 3. And because these lines have the exact same slope, which is negative 2, then there is no solution because they have a different y-intercept. So anytime you have the exact same slope and different y-intercept, you have parallel lines, and we should remember that from our previous modules. And when we have parallel lines, they will never intersect. All right, so there's no solution. So sometimes you're going to be given a systems of equations in a graph like you are here. And when you're given a systems, occasionally they're going to ask you to write the equations of those systems. So first, let's start with writing the equation of this line, okay? We're always going to start with our y-intercept. And here's our y-intercept, and the value of that y-intercept is negative 3. So our b value for this line is negative 3. Now we have to find our slope. So to find our slope, how did I go from my y-intercept here and get to this point? Well, I went up 1, 2, 3, and I went over 1, 2. So my slope is a positive 3 because I went up 3 and to the left 2. And when I'm going to the left, that's a negative movement. So positive 3 over negative 2 is going to simplify to a negative 3 halves x minus 3. So this is the equation of this line. Now I need to write the equation of my second line. And the equation of my second line, again, I'm going to start with my y-intercept right here. And the value of that y-intercept is b is equal to a positive 1. And then I'm going to see how I moved to get to this point. So that would be my slope. Well, I went down 1 and I went to the left 2. Well, down 1 is a negative 1 movement, and to the left 2 is a negative 2 movement. So a negative 1 divided by a negative 2 is going to give me a positive 1/2. So my equation for the second line is y is equal to 1/2 x plus 1. Now, the easy part, what is the solution to this systems of equations? Well, the solution is simply where the two lines intersect, and they intersect at this point, which has a value of 2, 0. My x value is 2 and my y value is 0. So that is my solution. And I will always list my solution as an ordered pair because it's an x and a y value. You're going to try check 1 and check 2 on your own, and you'll later be able to check those in Canvas to see if you did them correctly. And now we're going to move on to our next example. Okay, in this example, we have to graph the systems of equations and identify the solution. So the first thing we have to do is graph. And so to graph this line, we're going to start with our y-intercept, and our b here is 4 because that's the number that's by itself, the constant. So I'm going to go over to my graph and plot my y-intercept of 4. Then I need to move my slope. And in order to move my slope of 1, right, because even though there is not a number listed in front of that variable x, I know that there's an implied 1. An implied 1 then represents my slope. So a slope of 1, I can either go up 1 and to the right 1 and put a point, or I can go down 1 and to the left 1 and put a point. That is a positive 1 slope. And I connect my points and I draw my line. Okay, now we're going to move on to the second equation that we have, our second line. Again, we're going to start with our y-intercept of a positive 1. So here's positive 1 on my graph. And I'm going to move a slope of negative 2. Now again, negative 2 slope, I can either go down 2 into the right 1, or I can go up 2 into the left 1. Now that I have 2 different points, or 3 different points really, I can connect my line. I can draw my line. And now I can see where those two lines intersect, therefore giving me the solution to both lines. And the value of that solution is 1, 3. My x value is 1, my y value is 3. So I simply fill in my solution as 1, 3. You're going to try this check on your own. And now we're going to move on to our next example. So in this example, we were given an equation, but neither equation are in slope-intercept form. So the first thing we need to do is write it in slope-intercept form, which means we're going to solve for y. So in order to solve for y, we are going to add 4x to both sides, okay? Because remember, to solve for y, we want to get the y by itself. Once we add 4x to both sides, we get 5y is equal to 4x plus 10. Now, the y is still not by itself, so I'm going to divide each term by 5. And so I get y is equal to 4/5 x plus 2. Well, even though it has a fraction, it is not any different to graph, because remember that fraction is our slope. So that's just telling us how we're moving on our coordinate plane. So I'm going to go to a positive 2 on my y-axis to represent my y-intercept. And I'm going to move 4 units up or down and 5 units left or right. Now, you'll notice here I am. I can't go up 4, 1, 2, 3, 4, because then I'm off the coordinate plane. So here I'm going to go down 4. And if I'm going down 4 and I need a positive slope, I need to make sure I'm going to the left 5. So there's my second point, and there I can draw my line. And now I'm going to move on to my second equation, which is x plus 3y is equal to 6. I'm going to subtract x from both sides, and I get 3y is equal to negative x plus 6. Then I'm going to divide all of the terms by 3. And once I divide all terms by 3, I get y is equal to 1/3 x, negative 1/3 x, plus 2. So I'm going to start at that y-intercept of positive 2. You'll notice that's where they're intersecting, but we're still going to graph our line. So we're going to go up 1. And here, because we have a negative slope, we're going to go to the left 3. Then I draw my line. And now I identify the point where the two lines intersect. And the two lines intersect at the value of 0 is my x value and 2 is my y value. So my solution for this systems of equations is 0, 2. All right, you're going to try that check on your own and then check it in Canvas. And then you're going to see that you have a practice page with 8 different types of practice problems. The first 4 are just like what we did in our first example. The second 4 are what we did in our last 2 examples. Once you've finished on your paper, I want you to go ahead and check your answers in Canvas to see if you did it correct. That's it. I'll see you in the next video.